Hello, my name is Piotr Kozakowski and I'm going to present Q-value weighted regression, a joint work with my colleagues from Google and the University of Warsaw. First, I'm going to talk about advantage weighted regression, which is the inspiration for our method. AWR is a very simple off-policy actor-critic algorithm. It consists of two regression tasks optimized in a loop, one for training the critic and one for the actor. The actor loss is weighted dependent on the advantages of actions, so the actor learns to favorize actions that performed well in the past. AWR achieves very good results on the Mujoko tasks, but it is not very sample efficient. It requires a lot of experience to learn. Please notice the x-axis on those plots. It's in the order of millions of interactions, which is quite high. But AWR is competitive in the offline RL setting. It performs on par to the BCQ and BER algorithms, which were designed specifically for offline RL, while algorithms such as TD3 and SAC just fail in this setting. In our work, we analyzed the possible causes of the low sample efficiency of AWR. Please recall the policy update of AWR. It is weighted regression towards the previously performed actions. We discovered that for small enough replay buffers, where for each unique state we only have one action stored in the buffer, the optimal policy for this objective copies all actions from the replay buffer regardless of the advantage weights. This causes the policy to just repeat the actions performed in the past without improving upon them. This behavior for some small replay buffers could explain the low sample efficiency. QWR overcomes this problem by considering multiple different actions for every state. During actor training, we sample multiple actions from the behavior policy and use it to compute the loss. This prevents overfitting on actions in the replay buffer. To be able to evaluate different actions from the same state, we use a Q network to compute the advantages of actions instead of the Monte Carlo returns. We train the critic using a backup operator similar to the Bellman backup, but with action sampling, so we can handle continuous action spaces. This corresponds to evaluating an improved policy, selecting better actions than the behavior policy, to provide a better baseline for advantage calculation. Here are the results on the Mujoko benchmark, comparing QWR with AWR, SAC and PPO at the budget of 100,000 interactions. As we can see, QWR is much more sample efficient than AWR on the evaluated tasks. It performs on par to SAC, getting much better results on Walker and Hopper. Also, QWR works well on Atari at the same sample budget. It is better than Rainbow, outperforming it on 4 of the 6 considered tasks. Notably, those results were obtained using the same hyperparameters as for the Mujoko experiments, without any additional tuning. QWR also performs well in the offline RL setting, comparably or slightly better than AWR on the considered tasks. This is with the same hyperparameters as for the online experiments, again without any additional tuning. So to summarize, QWR is a simple yet effective RL algorithm. It is based on the AWR update rule, but with action sampling. It has a Q-network critic with extra improvements similar to Q-learning. It is much more sample efficient than AWR, on par with SAC on Mujoko and 100,000 interactions. It is better than Rainbow on Atari at the same sample budget. And it performs on par with AWR in offline RL on Mujoko. So thank you, and if you'd like to hear more details about our work, I invite you to our poster.